Well, hello PreAlgebra. Welcome to another week. This week we're continuing our work with our two-step equations, but more specifically we're focusing on how to write our answer as fractions. So all of the steps for the work itself will be the same, but our answers won't be whole numbers. So let's dive into some examples and see how it all pans out. The first example today is going to be 7x plus 16 equal to 19. So the goal and the ideal is that once you see this done, once you see it happen, it makes some sense and seems pretty intuitive. If not, please email me, reach out. I want to be able to have it make sense for you guys. Because the steps that come first are the same steps that we saw last week. The whole goal is to solve for x. So we're going to take care of our addition and subtraction first, and then our multiplication and division afterward. And so in this problem, we're adding by 16 to our x. So we have to subtract by 16 on both sides. Boom, boom. So that leaves us with our 7x equal to the 19 minus 16, which is 3. Now, as you guys may have already predicted, 7 does not go into 3. So when we divide by 7 on both sides to get x by itself, the 7s will cancel out on the side with the x, just leaving us with x by itself. But on the side with the 3, because 7 doesn't go into it, we just leave it as a fraction. We would leave our answer as 3 over 7. So when you go to type it into the computer, you would be typing in 3\7, just like that. And so, ladies and gentlemen, that's all it is. When you get to the end and you do your division, you check to see if they can be divided, and when they can't, you don't worry about typing in a decimal. You don't worry about even typing it into your calculator. You just leave it as 3 over 7. And so, of course, Desmos and other online calculators can also help double check to make sure that your answer is complete. You could type 3/7 into Desmos and look for any reductions or any other sorts of fractions that come along with that. And so, let's go and take a look at another example here. So, the next example is 4x minus 3 equal to -8. So last week we practiced a lot with negatives as well, so we're going to continue that practice just so we can keep our skills sharp. We want to get x by itself, take care of our addition and subtraction first, so we're going to tackle that -3, the subtraction by 3 on both sides. So first we're going to want to add by 3 to undo the subtraction by 3. So our value of 4x is equal to -8 plus 3, and calculator geniuses, you're able to plug that in. If we're losing 8 and we gain 3 back, we still are losing 5 then. So another way to say that is if we owe 8 and we give 3, we have 3 to give, we still owe 5 afterward. So then our goal is to get x by itself. We want to divide by the 4 on both sides. And just like we said before, once you do that division, you're done. 4 doesn't go into 5 at all. And so your final answer is just the x is equal to the 5 over 4 as a fraction. The thing that we have to track here is how the negative works. Now, a negative can go on the top or the bottom or just in front of the fraction. So it can go on top where the 5 is at, it can go on bottom where the 4 is at, or it can just go in front. All three of those are correct and literally the same when it comes to writing a fraction. Just one negative in a fraction makes the whole thing negative. That's why we say a negative divided by a positive is a negative, and a positive divided by a negative is a negative. The thing that's different is we're working online. And so if you want to type this into a computer, if you guys aren't already familiar, you want to type -5/4. And that's how you type in the negative fraction into a computer. Ladies and gentlemen, last example. Let's add a page. So in this last example, we have negative 2x minus 3 equal to 7. So first things first, take care of our addition and subtraction. So we're going to add by 3 on both sides. That leaves us with our negative 2x. And then 7 plus 3 is 10. Remember, we're adding by 3 to undo the subtraction by 3 up in the problem. Now, the 2 is also negative, but the negative isn't the action here. That negative on the 2 isn't subtraction. It's representing a negative number being multiplied by x. So that's why we divide by negative 2 on both sides. We're undoing the multiplication, and negative 2 is what we're multiplying by. And whatever it is we're multiplying by, we want to divide by to get x by itself. And so, divide by negative 2 on both sides. The negative 2 on the side with the x just leaves x by itself. But on the other side, we have that 10 over negative 2. So, we have 10 over negative 2. Now, ladies and gentlemen, this is a fraction that can be reduced. This actually just gives us a whole number, right? 10 divided by negative 2 is negative 5. But what if that was in reverse? What if we had the fraction x equals negative 2 over 10? The answer is not 5. To reduce the fraction, we look at the number that's common in both the top and bottom, and we divide by that number for both. And so, for 2 and 10, the number 2 goes into both. 2 goes into itself, and 2 goes into 10. And so when we divide by the 2 on both the top and bottom, our value of x is then equal to anything divided by itself is 1. That's what I mean when 2 goes into itself one time. So negative 1 on top, and on the bottom, 10 divided by 2 is 5. So, ladies and gentlemen, that's the reduced fraction. And so just as an example here, negative 2 over 10, you're dividing both of them by 2 to get negative 1/5. So that's if you want to reduce a fraction. But over here on the left, it just so happens that we ended up getting a whole number. Ladies and gentlemen, thank you for your time and your work and your efforts. I look forward to seeing you guys later this week. Take care.